Awesome. So, hello everybody, and welcome to the second day of our Liberate Data week. This is dApp day, and when I woke up this morning, there were like two wonderful messages in my chat platforms. The first one is that B has a new release, which is version 0.5.1, if I'm not mistaken. And also BJS, the accompanying library, also has a new update. So this means everybody in the hackathon that today we can like basically definitely start hacking for real, because we have things like feeds in there. I hope you all had a good night's sleep. I personally was a little bit hacking last night, but not too much because I definitely was waiting for this release to do it for real. So tonight is gonna be the night. Some housekeeping messages maybe. We released a document in the Swarm, in the B support chat. It would be really convenient if you could add your project to that list, so other participants sort of get a view on what is being worked on and where you can join, basically. Today, let me go quickly through the program, if I can find it. Okay, so that day. So first off, I'm going to have an interesting conversation with Daniel Nagy, who is one of our brilliant researchers in the Swarm team. After that, you will hear from Attila, who is I think I can say the dev lead for the BJS team. And he will be showing you how you can build dApps with BJS. Dan and Gregor will basically show you how FDS.js works. It's a library to connect to data networks and do storage. And at 15:50, approximately, of course, we'll have a workshop with Gregor and Kent with Linum Labs, and they will be showing you how to do Fairdrive and Git Login. And then at around 16:20, 16:30, we will be closing this event for the day, and we can start hacking finally. If you have any questions, please, I'm literally looking at the Telegram group here. So you can just ask anything or give feedback. You can, oh, Gregor says it will just be Dan showing off today. That's a shame, Gregor. It's always fun to see you hacking stuff. So if you have any questions or remarks, please do that in the Telegram group or, of course, here in the chat. So let's get this thing started. Daniel, can I please ask you to unmute and show your video?
Hello.
Hello. Okay, I'm gonna try to get a different view here because, yeah, this is way better, I think. Ah, there you are. Now I can see you perfectly. Hello. What a nice sweater you are wearing. I'm a little bit jealous of that. I don't have one like that. So Daniel, we are gonna talk a little bit about dApp Day. So today is all about our hackers building dApps on top of Swarm using B. I know you did like a really cool presentation in one of our last events where you explained what Swarm is, and maybe you're tired of it, but I would love to hear from you. What is Swarm, but in the context of dApps? Like, why do we need Swarm for dApps?
Swarm is at its heart a distributed storage platform, which means that at the very rudimentary level, dApps can use Swarm to just host themselves. So the way you get the dApp running on your computer is by downloading it from Swarm. So basically, you get a Swarm reference, you follow that link, and the dApp starts on your computer. So that's like the very rudimentary, most basic thing for which dApps can use Swarm. And for that purpose, they don't even need to be aware of Swarm. It just functions as a static web server, but distributed. Now, From time to time, we get questions like, can we host dynamic pages on Swarm?
I was literally just about to ask you, like, but what with all these PHP websites and you know all these
Right,
dynamic server kind of languages?
right. So that cannot be done in a decentralized trustless fashion. So when you're writing a dApp, it's not, you should free your mind from the client server architecture. So here we are in the peer-to-peer context, peer-to-peer universe, which means that the business logic of the dApp is also executed by the client on the client side. However, these interactions are such that the fact that the computation is performed correctly is verifiable by cryptographic means. So when you do something, then you apply, you know, a digital signature, hash, all sorts of neat tricks. But in the end, when you submit it and other clients see, they can verify that you did, well, first of all, that it was you and that the computation was correct. So the paradigm is very, very different from the client server model. So no, you cannot host PHP pages on Swarm, at least not the way you can host them on a web server. But rather, what you do is if you have some dynamic data, which are also hosted on Swarm, then your dApp can do some modifications. You get a new root hash of the data set because calculating the root hash is very efficient. So you can modify even large data sets at relatively little cost. And you get a new root hash. And then this root hash is kind of the new state of that data set. And it needs to somehow get to all the other users. And there are two ways to do that.
Mm-hmm.
The more reliable but more expensive way is to submit it as a transaction to the blockchain. So we have this nice little consensus machine called Ethereum,
Mm-hmm.
where if you submit a transaction, it's carved in stone, and once the root hash is available to everybody, every client has. So it gives you instant consistency. By instant, of course, I mean the proper confirmation time on the Ethereum network. But once you have that, once you have the new root hash in the Ethereum blockchain, for example, as an ENS, Ethereum
Mm-hmm.
Service Record, then it means that you have updated the state.
And what is
Now,
the cheap way?
well, the cheap way is Swarm feeds. So we have this thing on Swarm called feeds. It is not entirely a consensus mechanism, so you cannot count on every client getting the feed update at the same time or even getting it at all. So feeds also need to be from time to time anchored to the blockchain, but with clever programming, it can be done in such a way that it happens relatively infrequently and the costs are somehow borne by the parties that are willing to bear those costs. Although here I must say that currently transaction fees on Ethereum are outrageous. They are ridiculously high.
Yeah.
So dApp development is also subject to the scaling pains of Ethereum, but we are quite confident, at least some of us are quite confident that Ethereum will overcome these things. And with Ethereum 2, when we are going to have shards, transaction costs are coming back to normal. And then basically what you can do is you have feed updates, which are cheap, and all those who are monitoring the feed at the time of updates are getting
Yeah. Can I can I go a little bit deeper? I know you're
Yeah,
not
sure,
here.
you can.
Yeah, I hope you're not here, of course, to talk about Ethereum, but it's such an important you know part of what we are doing. Of course, do you see this you know like the scaling issue? Do you see this as Yeah, for instance, if you look at the evolution of the iPhone, like the first iPhone, it was basically compared to what they are doing now, it was a brick, with low battery life, etc. So do you think Ethereum will scale also like we have seen in other technologies, where this is just like a phase where we have to go through?
Yes, I think that, I mean, it's on their roadmap. So in order for Ethereum to be useful for all the kind of things that we're going to be showcasing today, uh, it must overcome the scaling issues, and there are some very bright people, very well-funded, well-motivated, bright people working on these scaling issues. So for those curious, I would recommend Vitalik's paper about the roll-up-based future, where basically his current vision is that there will be a relatively small number of shards, giving 1 or 2 orders of magnitude scalability compared to current Ethereum. But from that point on, the bulk of the transactions, which are just coin transfers and which are not proper smart contract interactions, will move to some layer 2 solutions, probably ZK rollups or some other rollup like technology, which means that the passing of tokens will be taken off the blockchain for the most part, and that will free up the capacity of the consensus machine for the kind of things that we want to use it for.
Cool. So I also want to touch on this topic, because I think we don't do this enough. So we have been talking a lot about BZZ as a protocol and how storage works, etc. But I think one of the also very interesting features is, of course, messaging, the PSS protocol. Could you talk about how this how are we as dApp developers, like how are we supposed to use this and integrate this as in our app? And I know that, of course, the simplest example is like, okay, create like a chat app where nobody can trace your conversation, etc. But could you go into more specifics, like why could we use it, or why is it there?
So dApps, if they are interactive, and there are some users working concurrently on some data, then you need instantaneous communication between those online in order to communicate the state changes that they introduce. So for example, suppose you have some whiteboard application where multiple users can draw stuff. And of course, eventual consistency through feeds and even the blockchain would work. So if somebody joins a day later, they will see everybody's drawings on the whiteboard. However, for those working on the whiteboard concurrently, what you need is that every stroke is immediately sent to the other participants so that they can see it. So for example, that is a use case for PSS, where you need instantaneous communication to provide an acceptable experience of concurrent editing of some content. So that would be one example.
So it's like Google Docs editing a Google Doc kind of.
Yeah, exactly. If two of you are editing, you want to see what the other guy is typing, not when the transaction eventually gets committed with the new root hash into the blockchain, but you want to see it immediately as they are typing. And for that, what you need is instant messaging, and that's what PSS provides you.
What would you see? So this is a hack week, so we do have some talks, of course, but in the end, the idea is for this week to have on Sunday, a couple of apps or a couple of projects that are running on top of Swarm and Bee. What would you like to see? What kind of app or project would you like to see Sunday?
Well, I'm mostly enthusiastic about things that work on top of large data sets. And as far as I know, there are people already massaging OpenStreetMap. And it would be very cool to see some geospatial application to be developed on Swarm so that it can use the data set from OpenStreetMap and let people do something with it, like share their position or edit it or annotate it or something.
Yeah.
So I think there are some teams that are working on something like this.
Do you think you have been thinking about Swarm and a world where Swarm is a reality? You have been thinking about that a lot. Did you ever come up with like a kind of app or a kind of solution that doesn't exist yet because it is not possible because you need Swarm to make it possible?
Yeah, so I usually talk about these knowledge databases, of which OpenStreetMap is one. Wikipedia would be another example. So they all grapple with the problem of official truth. And what I would really like to see on Swarm is a public data set where you don't have you simply don't have this problem, because the kind of operations that people do with distributed source control, like Git, like forking, merging, rebasing, these kind of things, you can do with data on Swarm. And it would be nice if we had a kind of a Wikipedia-like application where for every topic that is contended, where there are multiple opinions about certain topic, where you could see like around which opinions people cluster, what are the different perspectives on it, and of course you can choose which perspective you trust or which perspective you even want to see. But and there's still plenty of scope for editorial work, for somebody to to moderate and edit or curate a version of this data set, and
Yeah.
people can relate to that. But
Yeah.
basically, I think that what's missing from the Web 2 world is what we call permissionless publishing. That if you have something to say, if you have enough bus to store it in the swarm, then you should be able to store it in the swarm. And who looks at it, that's a different question, but you should be able to
Yeah, I think you're
take it.
touching on a very important topic there. Like it seems like the internet now is who pays for the storage, or who the person or the company basically that can still pay for all the storage or even the communication, they get to say sort of what is real or what people see. Do you believe, and I know this is a very mundane philosophical question for someone like you, so I hope you don't mind me asking you. But do you think it is important for us as like a society to have one reality? And I say this in the context of all the fake news and people who like really believe different things than other people, and they seem to get into fights and polarization by that. Do you think this is a problem? Like, do we even need like one truth?
So I think that consensus on reality is nice and even necessary, but let's not pretend that there's consensus where there's none. So I think that as long as there are different opinions on certain topics, it is better to be honest about it and to somehow represent the fact that there's no consensus, rather than faking a consensus. So I think that fake consensus is just as bad, if not worse, than fake news. And I think that there are various methods by which people can choose for themselves what to believe in, and I think that there should be some mechanisms, institutions, whatever, that help people on converging on a reality, but it shouldn't be fake. Like we shouldn't pretend that there's a consensus where there's not.
Okay,
That's
that's
my take
also,
on it.
yeah, I think that's a wonderful opinion. Daniel, this is all we have time for. I want to thank you from the bottom of my heart for you being here. It's always really interesting talking to you, and I love that you can share your thoughts with especially this group of people who are like the builders of our ecosystem. So thank you so much, and I hope to see you soon.
Well, thank you for the conversation. It was very pleasant. Thank you so much, Michelle.
Thank
Bye
you.
bye.
Bye, Danny. So yes, Danny, thank you so much. I look forward to rewatching that conversation. The problem is I have a job to do, and this makes for, you know, I want to listen back to this conversation. I think it's always so interesting to hear Danny's take on things. Next up, we have Attila. Attila, are you there?
Hello, everyone.
Oh, so Attila, I want to congratulate you. I think I hope I'm one of the first people to congratulate you and the team on releasing BJS. For me, it is sooner than expected, and I can't wait to start playing around with that. So I hope after your presentation we can still have like a couple of minutes to speak about some things I was curious about. But first, I will let you do your thing. So please go ahead.
Thank you, Michelle. I would like to share my screen. Let me see. Can you see my screen? I prepared a short presentation.
Yes. Yeah, it's all working.
Cool. Oops. Wow. Okay. This is not what I expected, but I will just show you like this. Is it okay?
Yeah, sure. I can see it. No worries.
All right. So I'm going to talk about BJS to build your own dApps on it. And first of all, I would like to talk a bit about what BJS is, what dApps are, and what B is actually. So because I have heard from some people that there is a bit of confusion around these things. So Swarm is the decentralized storage and communication system that we all would like to use, and B is a Swarm client written in Go. So basically, you run B nodes, and that the B nodes this the data. And BJS is a JavaScript library for using the B APIs easily. So B provides HTTP APIs, and you can use that directly as well if you'd like. But when you are working on application development, sometimes it's easier just to use a library that also provides some types for you and some definitions and some convenient functions to make things easier. And this is what BJS is. And dApps are decentralized applications. So basically, decentralized applications are ones that are hosted on decentralized platforms. So they cannot be deplatformed. Nobody has once you deployed it, nobody has total control over it, so cannot revoke it. And basically, Swarm is one of those platforms which allows you to build these kind of decentralized applications. And we hope that people will like BJS for doing this. So the current functionality of BJS is basically the chunk bytes files collections upload and download functionalities. So you can upload and download data to and from Swarm, and you can use tags to track your data on the network. So if it's uploaded, if it's synced, and everything, you can use the local pinning functionality of B to to make sure that your files are always available once you synced it to your node. We have PSS functionality, which is it's a private messaging part of Swarm. So you can send anonymous, private, encrypted messages between the nodes. And we have also the balance checkbook settlements functionality. So you can check your node's balance. You can even settle the checks and everything. So take care of the money basically and the accounting parts. And coming soon is the single owner chunks and feeds, which I think is a unique feature of Swarm, because that allows you to store data privately and have your own space that you can control. And also with feeds, you can have updates without having to make transactions on the blockchain. So that's very exciting. And I prepared with some links and I prepared with a demo. So basically, I would like to show you what we have now. We have a website where you can have the documentation for BJS. You can, your usual things, getting started, how to install it with NPM, how to use it from JavaScript and TypeScript. It is written in TypeScript, so you also have type informations as the first class citizens. And yeah, we have some examples, and you can check this out. And I prepared with a small demo, which is also it's one of these. It's similar to one of these examples. Basically, it's a React app. It's a basic React app. It was created by the Create React app, and you can see it's the usual suspects, basically the template React project. The only difference is that I also installed the Ethers for BJS package, which is the official BJS package. And then if you download this project that you can find here, I will provide the links in the channels later after this talk. Then you can start the React app with npm run start, and then you can open this application in the browser, and it's very sophisticated. It looks like this. So basically just a file picker and a submit button, and I will show you the source code because we will look at the source code. So this is like a very basic one file React application. You can see it's a div, it's a form inside, there is an input field and an input button. And what we do here basically is that we select one file with this file picker. Once we selected the file, then we set it in the React state. And then when you press the submit button, then the handle submit is called, and then it gets this file, it uploads this file to Swarm or B. It downloads this with the hash that was returned, just to make sure that this worked. And then we set the link of this file. And then once the link is set in the application, we will display this link. And then I will also show you how the B initialization happens. So basically you have to import B from Ethersphere BJS. You have to provide a URL. It is one of my running B nodes locally. Then you create a new B instance. And after that, on this B instance, you have the functionality that you can use, like download file, like file from collection, pin collection, PSS, receive, send, subscribe, retrieve tag, whatever. And so this is the example. Let's try this out. So we will choose a file. I chose a Swarm logo, and then I press submit, and then here I have this link. So it returned actually a B file API link, which looks like /files and / the hash of the file. This is a content hash of the file. And if I click on it, it takes me to this file that I just uploaded. So that's very simple. We can upload another file, upload it, and then this is a transparent SVG logo that I just copied from the website. So this is the basic demo, and then of course you can do multiple files as well. But I want to show it to you. It's a bit different how it works, and actually, yeah, let me just show you. So I prepared with the branch in Git, and then I just switched to this branch called files, and the difference is, if you want, is that it's capable of handling multiple files. I added multiple property to this input element, and then I also have multiple files in the state, and then basically I call the upload files instead of upload file on B to upload multiple files. But what happens actually is a bit different in the background. So when you upload one file to B, then it creates a file on B. But if you upload multiple files, what happens? It creates a so-called collection. And the collection is basically something like a dictionary or a folder in an operating system parlance, so that it's a hierarchical structure of multiple files. And with that, you can upload websites or any kind of data, basically, that you store locally on your disk in a folder. So here, just to demonstrate this, we will select multiple files and then submit it. And then what you can see here is that the difference is that now we get back a link which doesn't point to files, because files endpoint returns you a single file. But the BZZ we use the BZZ endpoint, which is a general resource endpoint. Basically, you give a hash to Swarm, and then it returns you, in this case, this collection, which represents this directory with the files. And then once you have that, you have to, well, there are like many features that you can do. Like you can, when you set up a website, for example, you can set an index.html as a default file, and it will return your website. But in our case, we have to pass in the file name, and then basically add the file name to the end of the path, and then it will return you this file name. So in this short time, I only had time for this demo, but we have, well, we just started working on this, public releasing this BJS, and we just started working on the documentation, but we already have, I think, enough information to get you started. Of course, there are like bugs, and we say that this is alpha quality, but we wanted to release this for the hackathon because we think that this might give you a boost for building applications. And please feel free to reach out to me. I'm available on Telegram and also Mattermost and GitHub. So use these channels, please. I will post the links after my talk to all these channels. So that was my presentation, and now let's get back to you, Misha.
Thank you so much, Attila. It was very nice seeing that. It seems like a very simple thing, if you look at your demo, but I know how much work and thoughts and brain power is behind this. And yeah, again, congratulations. One question I have. So when I upload multiple files, is that like recursively? Can I upload a directory with directories in it and files in it and directories in it?
Yes, sure, you can do. So it will automatically create this. Yeah, so that's possible, of course.
But as you showed, like if I just go to the hash, it will not show me sort of a directory or a file listing, right?
Yeah, not yet. So yeah, it's possible to get back this information. We don't have this in JavaScript, but yeah, of course it's available. And hopefully soon it will come.
Awesome. Do you still have time? I mean, could you, if you have time, could you explain maybe a little bit? I just want to make sure that, as Victor said, like we need to get out some, how you call this, like primitives, so like basic concepts. For instance, Dimitri just asked like, what is an SOC and what is feeds, right? I have been struggling to understand this as well. So could you try to explain that?
Yes, sure. So basically Swarm can handle right now, or can store two types of chunks. There are the content address chunks, which is basically your data you upload. And if you upload the same data twice, you get back the same hash, because this hash is based on the content of the data. But with that, if you cannot really change things. And also you cannot really prove the ownership of the data. It's possible to put like something inside your data, but Swarm also has another way to store chunks, and they are called single owner chunks, which means that if you have a key pair, for example, your Ethereum key pair, you can create chunks that are signed by you. When you create the chunks, you have to sign them, and then Swarm will let you upload them, and then you can get back the hash of this chunk, and then if you pass it to someone else, then someone else can also verify that it was signed by you. So with that, you can create private chunks basically that is signed by you, and then you can make sure that nobody else can write them, just you. So, and with that, many things become possible, because then you can basically create data structures with the help of this on Swarm. So for example, one of these data structures that we have in Swarm, and I think it's unique to Swarm, is these feeds, which is basically a clever way of like deterministically create these single owner chunks so that they can be found. For example, if you take a for example, you can have these single owner chunks that that contains an index. When you generate the chunk itself, you can deterministically come up with a way to generate an identity, or like it's like an index of this chunk. So when you get back the address of these chunks, you can tell that it was the first or the second or the third or whichever. And then basically you can if you share this information in an application or with someone else, then for example you agree ahead that, okay, so this is my place and I will put data there for you. And then okay, then you say, okay, I'm waiting for you, please I will just pull the information if you have written the data to the 0 index. And then I'm doing my first write to the 0 index, then you are polling that, and then you will fetch it. So you will get that information, and then you will poll the next index. So then you move ahead. And then once I want to send you an update, then I will write to this next index, and then you will get this update. And with this, basically, we can have mutable data, because then we can have deterministic updates in an agreed schema, which we both know. And then it can also be used. So if you can set up this one-way communication, then in a similar way, you can set up two-way communication. And after that, basically, you have like channel for communicating any kind of data.
Yeah, so that's a really good explanation, I think. Another question I had was, in how far is PSS supported in the BJS lib that you just released? What can I do with PSS?
So you can send PSS messages and you can receive PSS messages. The only thing that it's good to keep in mind is that this PSS is a private API, in a sense that like you cannot use this over gateway, And also you have to understand that it's quite computational heavy, because basically when you send a PSS message, it basically mines a chunk. So it basically creates a chunk in a format that that makes sure that the other party will receive it, and but nobody else can decrypt it. So this is a computationally expensive operation, and that's why it's not allowed on the public gateways. So you have to use your private gateway or private node, and basically you can use it to send private messages to other private nodes.
Yeah, I understand. So yeah, another question. I know we're going over time, but you know, we'll try to strip up some other time somewhere else. So I think, I mean, my dream is to have BJS working as a light B fully in the browser. Will this? I know. Can we look in? I know you just released, and you know we're happy with everything you did, but I still want to push you to look into the future. And will this ever be possible? And is this like, you know, far out there, or is this something that will be feasible?
So there are some current limitations in the browsers regarding what kind of connections you can make, and basically, for security reasons, the browser cannot handle incoming connections. So it can initiate outgoing connections, but it cannot accept incoming connections. And that's a pretty serious limitation with a system like B, because it, you know, all the nodes are accepting incoming connections as well as initiating outgoing connections. So there are some ways to overcome this. We are experimenting with these kind of things, but it seems that right now it's only possible with some kind of either some kind of browser extension, or or using your local B node with the library, or having browser support, just like what Brave browser did with IPFS recently. So there is hope, and we will work to figure out which is the best way forward. So yeah, that's one of our biggest goal for this year, actually, to figure this part out. And I'm positive that we will see some kind of solution, which may not be like, mainstream ready by the end of this year, because this may affect like changing browsers. And well, it's not an easy thing, because the browsers are actually controlled by those exact companies which are like currently controlling the web itself. And yeah, they are not, I guess they are not a huge fan of these kind of projects that we are working on. But yeah, but that's why we are here and working on this to make sure that this happens.
I feel a B browser coming, if I hear you correctly. Anyhow, maybe this could be an idea. So Gregor has 2 comments. Purity browser for the win. I don't know what he means by that. Does that ring a bell to you?
Yeah, so one of my colleagues in the BGS team is called Victor Toth, and he has this pet project called Purity Browser, and he really wants to explore this direction. So
I see. And then Gregor also is asking, will you rewrite swap chat with BJS?
Yes, once we have the SOC merged to BJS, which I'm 100% positive is going to happen this week.
That's great news. Thank you so much, Attila. As always, great talking to you. Can't wait to meet you again in the real world. So yes, I'm gonna go to the next topic because we went way over time, but that's okay because I think this was very useful and interesting information. Thanks, Attila. Next up, next up is my good hacker friend Dan, who is going to show us, well, the title says using FDS.js to connect to other data networks and storages, which is quite interesting. Dan, are you here?
I am.
There you are, looking great as always. So then, are you as excited as I am with the releases of B and BJS today?
I can't tell you how excited I am to work with the single owner chunks and get swap chat working again. Swap, not stop.
Stop chat. Awesome.
Away. But yeah, no, I'm super excited, and actually I've been so excited that I've been jumping ahead and digging into the code, as we will see. As we'll see.
Yeah. So yeah. It's all. I'll just stop conversing with you so you can just show off all that stuff. Stick around after your talk because I definitely will have some questions for you.
Okay, I'll look forward to that.
Yes.
Okay, well, I'll prepare this short presentation, so I'll share my screen. Is that visible?
Yeah, that all looks good.
Okay, so my presentation is about using FDS.js to connect to other data networks and stores. First, a little bit of a history of FDS.js for those who don't know. So it started off with Fairdrive, which was a simple unencrypted file transfer app that we built on Swarm. And it's actually really way too easy to do that with Swarm. So we decided to make things more difficult for ourselves, and we added Diffie-Hellman-based encryption and used ENS to store the public key via the public key registry and do the usernames element for the discovery of mailboxes. And added all this in. There's quite a lot of R&D over time, and then we realized this was like really useful stuff. So let's pull it out into FDS.js. Then after a while, then we started like developing other applications on FDS.js, and we realized that we needed to add something that enabled us to have different mailboxes, essentially, for different applications. We made a chat application called Chatty, today did, and after those messages started showing up in Fairdrive, we realized, oh, we've kind of got something here. So we kind of accidentally came across the interoperability and then built it into this this extra library we're experimenting with called Multibox. So, I mean, FDS.js it was an R&D process when we were building it. It wasn't perfectly formed, but I mean, it was very powerful and still is. So yeah, Multibox is an experiment to find out how apps can interact with each other's data, and then hence how this is related to the topic. So the Multibox, like on the FDS.js GitHub repo, is visualized as these pigeonholes. So the idea is that you would know where somebody else's pigeonhole is, and you would go and put the data there and encrypt and encode it in such a way that they would be able to then later go find their pigeonhole, get the data and retrieve it. And that's kind of like what the talk is about. So for the more sort of like technical coders, since we're in a hackathon, this is what a simple chat application, or actually it's sending a file from a web form in this case, looks like in 9 lines. So you just instantiate FDS. I left this in just to show that it literally is this easy. And then you create an account, send the file to Bob, and then this is the Multibox address here. So it's in this like file directory format. And you can pick that to be whatever you want. And then on the other end, you'd have your webmail app, and here you just unlock the Bob account and then go check that box in the Multibox and you'll get your file. So that's the idea of Multibox. Now, I guess some of you might be thinking, well, we can do this in Web 2, so what's so special about this? Why is this so important? The answer is like, what is actually happening in your networks? And it's kind of a black box, and it takes a lot of exploration to kind of find this out. So what I've done is I've done some artist impressions of some diagrams this to kind of try and explain it a little bit more to people. So this is what it looks like in the current present day. You have your server-client relationship. So you would have send your file to maybe something in the Amazon Web Services, and then maybe that would come back through Microsoft Azure Cloud, and there's you at the bottom, you're the client. And then the situation we're trying to move towards is a bit more like this, where you're the B and you have the key, and then all of the data are there for you to go and find wherever you want. And if you've got the key, then you get to unlock them. So this is a fundamentally kind of different situation, and all of the data is then shared across the whole of the swarm. And if you know the right location, you know how it's encrypted and how it's encoded, then you get to have it if you've got the key. But if you don't have the key, you can't have it. Now, you've seen the swarm address hash, I'm sure, which is a 64 character hex string. And what that represents is the address of data within Swarm there. As Attila was just speaking about in the previous talk, you've got your content address chunks. So the address is determined from the content, and then the single owner chunks. And we'll talk a bit more about those in the past. But this is the actual number of potential addresses in Swarm. So as you can see, it's an absolutely gigantic number, and it's actually just over a Google's. So Swarm is actual bigger than Google. So I've proved it here. A Google is 10 to the 100. Okay, and then now I've tried to prepare an artist representation of this as well. I've had to actually show this in the original thing because this is sort of too big. This was too big for Google Slides. So this is the whole of the disk, the entire address space. And then for single owner chunks, this is a special kind of chunk where part of this address space is sort of reserved in a sense, not exactly, but for an owner of a public-private key pair. So here,
Dan, I think your screen share has died.
Oh, I'm sorry. Okay, go back. So this is the artist's impression. Can you see that now?
Yeah, now we see your screen again. Yeah.
Okay, great. So the whole dark area here is intended to be the disk. So that's the distributed immutable store of chunks where all the data is stored. And then, as I say, there's a small section of that which is reserved for people essentially with a public-private key pair. So you have to have the key to be able to write there. But if you know the address, then you can go and read from there. And then within that, Swarm allows you to then write to specific addresses in this space. And the reason this is important is because when you get down to this actual chunk, right in the midst of the vastness of the swarm, determined by the your Ethereum address, and the topic and the identifier, not index, of the chunk, then you can go and fetch the data out. So the idea here is that if you have the key and the address and the topic and identifier, you go and put that data into the swarm, and then somebody else, any application, as long as they're given the appropriate information, can go and fetch that out. And that's what gives us the opportunity to have interoperability, because anyone can read or write to the swarm as long as you know the address and the information. And then just to go into a little bit more technical detail for the more technical of you, this is kind of what it boils down to. So on the way in, you start with your data, you encode it, encrypt it, and then that ends up in a location in the swarm, which you determine. And then on the way out, you go locate it, decrypt it, decode it, and then you've got the data. So it's a little bit repetitive what I'm saying, but the essential idea is if you know the encoding, the encryption, and the address and the key space, you can find it. Oops. Excuse me. So what's next for FDS.js? Well, we're in the process of porting it over, and that's actually very close, as I'll show you later. Once the single owner chunks are in BJS, then we'll start to move over to using that. And we're going to do some improvements to multi-box, make that a bit more gas efficient, and so on. And then coming soon, FDS2 with a sort of like rethunk API that relies less on blockchain and is more built around these swarm primitives that we've been kind of going through. And then, of course, the obligatory live demo. This is, well, preview of Fairdrop running on B rather than Swarm. So actually on Fairdrop XYZ, it's still happily running on the old Swarm network. This is the port over. See that this is the account getting built. A lot of the interaction, as you can see here in the network panel, is happening on the blockchain, but as it goes on, you'll start to see these interactions with Swarm. These 404s are totally normal, by the way. So, upload and send data. And then if we send it, and this is actually an example of what we've talked about. So it actually makes an entry in the multi-box. Oh, excuse me. Just send it to myself. In this case, you'll see during the upload process, it creates this connection here. And that is actually going and writing in the multi-box to say, go look in here in the disk for where we've left your messages and files using a single owner chunk. And so that's it for the presentation. So thanks to all the Swarm team for being the absolute best. And back to you, Michelle.
Yes, Dan, we also love you, so that's a good thing, I guess. Yeah, that's just wonderful. It's so cool that you can, you just demo it, and like this was a live demo, right? And like technically nothing is going wrong or anything, so that's
no, yeah, it's still working. Yep.
So
good.
I have so many things I would want to ask you, but let me first ask the people watching if you have like questions about this. Yeah, it's just too much. I love the way you visualize the disk. We should definitely use this when we are doing videos on what Swarm is. I think that's brilliant to just zoom in and out from this thing. Then I'm gonna be back to you, I think, at the end of this event, if that is okay. Mm-hmm. Because I think that our hackers that are watching and that are in the Telegram group, they will have some questions, but maybe it's good to come back to that at the end of today's live talk.
For sure.
So Gregor, I'm not gonna ask your question now. Let's come back to Dan and others to do a little AMA at the end of this day. Is that okay, Dan?
That sounds great. Yeah.
Okay, I'll see you in a bit then, because we're gonna move on and we're gonna now go to Kent in somewhere in South Africa. Fourie, how do you pronounce your last name?
Furry. Like Furry is a jolly good fellow. That's the easiest way.
Kent Furry is a jolly good fellow. So you're gonna show off again Fairdrive and Git Login app, but this time it's a hands-on workshop. Does this mean that I have to be following everything you do on my own machine, or can I just watch?
No. For this, I think I was going to also just start it off by chatting to you about Fairdrive, and I think possible ways forward for the application. I've got some good ideas as well. You connecting it with FDS, so it can be used without FairOS, connecting it with BJS as well, and then. While we were in the talk, I just mashed some code together to just basically get a kind of boilerplate repo up that can basically create create the account with Git Login from the invite. And my idea is that it would be quite easy to just put FDS at the bottom of that. So when you create your Git Login account, you can take that same one and create it in FDS. And,
okay, I'm gonna be out of the screen and I'm gonna let you show it all off because I just want to watch it. Okay, thanks, Kent.
No worries. Cool. So I would like to just start off by, let me just share that screen. I thought we would jump into the code a little bit more. Can everyone see this screen, or is it this one? Hello?
Yeah.
Cool. So just a little bit of history. Fairdrive is an amazing application built by our one and only Michelle. And it's been built to work primarily on FairOS DFS currently, but now that we do have BJS up and running, we've got amazing libraries like FDS.js, it is able to be ported across to these new libraries, but also work with FairOS. I don't think there should be ever a sort of hard line. We should always have access to kind of all the implementations that we want. And one of the things that was inside of the schedule was Fairdrive Connect, and Fairdrive Connect is specifically something that is mentioned inside of the Fairdrive repo, and it's an amazing idea, which is essentially something that Git Login tries to do on a contract level, on the blockchain level, but with application IDs. If anybody is familiar with how Portis kind of works, and I can give you a quick explanation. Portis, essentially what it does is, and I can quickly just log in and show you. Portis is a great wallet that does single sign-on, because you can put in a dApp ID and essentially kind of have this login with username and password. It's kind of what we try to accomplish with Git Login without being centralized. Portis is a great product, but we want to push forward the things that we're building here and want to get you guys building. So the idea was to store a dApp ID and to create a feed between the application that wants to connect to Fairdrive, which is hosted. And these sort of thin dApps will be able to kind of log in with a username and password if they've already created one, and create this connection with a feed, with a Swarm feed. And I'm sure you guys have learned a lot about that in the past day, last 2 days. But let's just jump into the code with regards to the quick thing that I put together for you guys, just to kind of step you through what I demoed yesterday. And you guys are more than welcome to pull down the code if you like and play around with it. So first and foremost, we have the Git Login which is hosted up on this endpoint, and I've got a little application here which just allows you to create an account with Git Login this is all it does, and it's just got just an easy component that has one nice big function which I'll walk you through now. If you guys want to get into the code, that I'll take you through the steps of what this does and where you can kind of plug in other applications for single sign-on. Cool. So I'm going to just pull across this code, if you guys, and please do ping me. I'll try and see. I'll pull down my chat box so I can see if people do ping me if I'm going too quickly. So I've got just a normal boilerplate. It's a TypeScript React boilerplate, and it's just got a basic sort of things inside of it, like a app entry point and everything like that. The most important one is just the create account component that is, the main component that has our lovely create account with Git Login connect. So first things first, because we're dealing with contracts, we have to create, obviously, a Web3 provider. Just create a nice HTTP provider. You can use a WebSocket provider. I'm using an inferior endpoint for this. And we just create an easy Web3 provider. You have to obviously have that to be able to send transactions and sign them. The next thing we're doing is getting an invite from Git Login Eth. And essentially what Git Login Eth does is when a kind of user that has an invite already creates an invite, it creates a invite wallet on the blockchain. I'll show you what that looks like right now. And this wallet is kind of seeded with a little bit of ETH. It's just enough to kind of get everything started so that people can have kind of gasless onboarding where I'm paying for the gas. When this account is created, it shows the private key and the mnemonic, because this is on Dually and it's not real money. And with that means that we can kind of use this as a starting point for almost any account creation. So if you were to instantiate and create an account with FDS by passing in the private key, and I have spoken to Dan about this in the past weeks, and it is something that can be done. So you could pass it in and have the same account on Git Login Eth as you would on FDS. So we create an account, create an invite, and we have private key. You guys, if someone grabs this and pulls it away, destroy my demo, that's fine. I'll just make another one. And we just for the purposes, we've opened up the mnemonic as well, just so we can pass that in. So let's go back to the code. Let's grab that one there. So we've got the invite from the mnemonic key. So this is a blockchain wallet. It's a wallet that has a little bit of ETH in it. And we essentially get that mnemonic or get that private key. We unfill that account or get access to that wallet. And we use that to send the transaction, which creates our new wallet on the blockchain. So this mnemonic and this mnemonic that we're using as an invite isn't the same one, but we create isn't the same wallet that we will be using for Fairdrive. It's not the same wallet that we're using for the one that we want to push into FDS, but it's the new one that we create over here. We can obviously omit we can show people the mnemonic beforehand if they want to type that in, but essentially the invite will be a totally different account. So the invite instantiates the wallet that essentially just pays for the creation of this new wallet on Git Login Eth. So we pass in the mnemonic, creates our invite wallet, we create a whole new wallet, and we encrypt this wallet with the password that we give it. And since we're talking to some contracts, we can just instantiate the contract. We set that we're going to send this transaction from the invite wallet address. So they're paying for the gas, not me. And I'm just instantiating the storage contract here just to show you guys there is another contract involved here. The logic one is how you speak to the contract set, and the storage one is the one that kind of stores all the data for it. Next, we take in the username and make a hash out of that. And then we send it off to this method called create username user from invite. And that basically takes the username hash. It takes the new wallet that we created, which is encrypted, and we basically pass a whole bunch of stuff that is important to be able to access this wallet with that password and be able to actually use it later down the line, pull it down and log in with it in other things. Over here, we can see that we're basically sending the full value. Over here, we can change it to basically say, the invite wallet, give me all of the balance and send it off to this new one. Obviously, taking into account the gas that needs to be spent. So obviously this invite is created with like 0.1 ETH. So we just kind of send the whole amount. And then obviously the data is just the encoded data coming back from this method, which we got ready. Next we send it and we sign it, and always good to add in some gas prices and the gas limits and those sort of things. Otherwise it might fail. And yes, that is it. We can run it now. So let me grab this again. and we've got our app here. So I'm going to create a new user, and I pop in my invite here, and we can kind of step through the code here as it goes. So this is what I'm notorious for adding debuggers, but they're very, very helpful. We first step through, we have our Web3 provider. We can kind of check, okay, cool. Is this populated? It is populated. It's got my GUI endpoint, which is a very, very good thing. I'm probably going to write an article soon about 10 gotchas that you get from working with wallet providers and Web3 and Ethers, because, man, it's very, very crazy. Next, we create the wallet from the mnemonic that we sent in, which is our invite. We've got all the stuff there. Next, we create a new wallet. We encrypt that wallet with the password that we pass in. We instantiate our login contract with our wallet invite address as the payer. Next, we're not using the storage contract, so just ignore that. Next, we get the username hash, which is just basically taking the username and passing it into like a SICAC 256 function, which is on Web3 and Ethers. Get the info, get the result, sign the transaction. Wait a bit because it's on GUI. And Bob's your auntie. We've got a signed transaction. And if I grab that, and I pop it in GUI, Etherscan, I should be able to see I've created my user. Oh, still processing. There we go. Awesome. So this has been sent. You can see it's been sent to a contract address. It's got all my data. It probably won't be able to decode because there's too much, but you can also see that it's transferred some cash to this new wallet so that I, as the new user, can do things with it. So let's just log out and let's just try and see if that worked. And hey, so we've processed now with signing in. We've given it our username, our password. That just gets sent off to the contracts as a read function. And basically what we get back is our wallet. And then we create our wallet and we log in. So then we can check our balance and our username hash. We can create more invites if we like. And if anybody would like an invite, please ping me. I am inside the Swarm support group as Kent or BMAC. So please, anybody that would like to get one of these or access to this, I'll push the code for it now. If anybody wants to try and connect Git Login Eth with FDS on some other dApps, I'm sure that Fairdrive could probably also, you could incorporate this into Fairdrive, which Dan showed you beforehand. And yeah, that is the demo. Just in time as well.
Yeah, you're like amazingly well timed, Kent. Yeah, I would like you to just stay around because we basically reached the end of the official program. So Dan and Daniel, Attila, can you guys come back, please? There you are. So, there you all are. Dan, what did you think of this demo by Kent?
I'm so impressed, honestly. I'm really excited to see that get lined up. It was always a problem that we had with Fairdrive, and it's kind of like there's a cheeky hand-wavy solution in the middle of it, which is that we've got a faucet that dispenses fake money, basically test money. And so I'm really excited to see this get implemented and be able to get rid of the faucet. And I think the invite system is like a great social a social approach to what's been a really difficult problem for the whole ecosystem.
Yeah, I also think it's so smart because this is like literally thinking outside of the box, or in this case, thinking outside of the technology. So I think many people have been looking for the onboarding and the gas problem solution, and then I've seen like tons of technological solutions where, you know, with contracts and like weird shit going on, and then the solution basically is so simple and so social, right? It's like you will always be onboarded by a friend or maybe your family that will say like, you have to try out this thing. And then, you basically give a little bit of gas, you just hand it out basically to people you trust, or, it's almost like you want to invest into other people's knowledge, right? Like, I want to share this with you. So I think that's really, thinking out of the box. And yeah.
Really neat, because it solves the UX problem and the spam prevention problem all in one. Thank you, Danny.
Yeah, I was just saying, like,
Yeah,
Danny.
exactly.
Thank you, Danny. Danny, when did you do this? I mean, is this a long time ago?
So it's been it's been brewing for quite some time. It was done together with Igor, so let's give credit where credit is due. So Igor Shadurin in Belarus, he did all the heavy lifting with the code, and I did the design, the specification of how this should work. And I think we found a sweet spot here.
Yeah. I'm just wondering, at what point did you realize, like, we're never gonna solve this? Thinking about code, we need to involve human beings.
Well, so the idea has been floating around since the early days of Ethereum. So if you know Alex van de Sande, who used to be the UX guy in the Ethereum Foundation, so he's been floating these ideas around since the beginning, but somehow getting right the exact mechanics was kind of elusive. So he even when he was graduated from the Ethereum Foundation, he started his own project called Universal Login or Unilogin, and raised considerable funds. But then he decided, the whole team decided to just give back the remaining money to the investors and fold up, because it's hard, and there's this battle of giants going on between the platforms and the browsers, and the platforms want to track you everywhere you go. So the browsers need to purge various local storages of data. So you can't really have secrets stored in the local storage. Then there are all these security issues that you don't want one app to be able to access the secrets of another app. So it's kind of a moving target, the whole browser ecosystem. And this particular mechanics that eventually got implemented as Git Login seems to be one which is resilient to all these changes and sufficiently intuitive, sufficiently secure, and it mimics the Web 2 experience for which users have already been accustomed fairly closely. So basically, you get a link, you click on it, and you get onboarded. But yeah, it took this long to get it right.
Yeah, I know that's something we all have to, I guess, learn to live with, to be patient and sometimes just wait on things that other people are developing or discovering even. So Petra, you have a question. If you want, you can just unmute yourself and ask it directly, if you feel like that.
Yeah, I don't know. I'm just wondering, in terms of, I know it's a decentralized file system. We're creating decentralized logins for decentralized storage, but this is a method of centralization within that decentralization, right? Does this expose doxing? Are there some use cases where this would not be beneficial versus, the obvious benefits from it, right?
Danny actually explained this really, really well in the first talk in March 2020 for Git Login Eth. I think, to paraphrase you, you said that the account really it's not one that is dangerous to get compromised, because it has very, very little eth in, but there's also a way for, if you do get doxed, you can essentially contact the person that gave you the invite, and they can go through a sort of like knocking the other person out, allow you to change your password. But you're not supposed to store a lot of eth on this. This is essentially just a kind of wallet to pay for small transactions and to pay for some gas. I think, you know, a lot of the work that we did as Lindum Labs was to get these contracts into into hard hat so that they can be optimized and run locally, so that you guys can play around with them and see, you know, maybe there are optimizations to make to understand the code while you're running it as well. We've got a deploy script there to get you started up so you can spin the whole thing up locally. Danny, maybe if you could say maybe where there could be optimizations against doxing for this.
Well, just as you said, so in a decentralized system, you don't have customer support, but you have the person who invited you. So they are assumed to be more knowledgeable than yourself. They have more experience with the system. They have been using it long enough to decide to invite you. And so instead of, you know, contacting Facebook customer support, you contact the person who invited you, and they have some control over your account, but you can cut this umbilical cord. So the idea is that this is a social recovery. It's called social account recovery mechanism, and you can do all sorts of sophisticated stuff. So you can say that, you know, those two out of those three people have the right to reset your account and let you choose another password or something like that. So the system is flexible enough to implement, well, maybe not any, but a very wide variety of social recovery mechanisms. It's just the default one, that your point of contact is the person who invited you. But you have full control in the sense that you can change this policy. So if you can designate, for example, you can designate another key for recovery, which is actually on your hardware wallet. So you say that if something goes haywire, then I'm going to plug in my hardware wallet and reset my credentials for Git Login. Does that answer your question?
To some degree, I guess. My concern isn't so much accessing wallets, but identifying wallets as nodes and communications between wallets as edges, and building out relationship diagrams across societies to identify networks.
So like social.
Well, that's a tougher nut to crack. So yes, who invited whom is basically out there on the blockchain, and it's public information. So it's not. So this particular mechanism does not hide that.
So I understand it as a public network tool, and that's got obvious applications. But I believe the more useful extension for me here is a non-public network tool. But I wonder if there's a way to abstract this that eliminates that, and I'm not sure.
So we haven't figured. So we don't have a solution for that yet. And to be honest, this wasn't a high priority. So first, we want to get the public network tool working, and allowing for. So it's particularly hard to do this kind of privacy on Ethereum precisely because of the gas prices. So if nothing else, you can track the path of gas money, like where the gas heaters are coming from. And it's notoriously difficult to hide. So I think that before Ethereum has some meaningful account abstraction, which they're working on. I mean, it's a problem. It's not only a problem for us. It's basically a problem for Ethereum as a whole. That doing untraceable transactions on Ethereum is hard. So now now there's things like Tornado Cash, where you can obfuscate the source of funds, but even there you need to be very careful with the gas money. So I think that we'd rather sit out and wait what Ethereum comes up with to this problem. And once there's some meaningful account abstraction mechanism or gas abstraction mechanism, then we will incorporate it. We don't, so the R&D for this particular problem, I think, belongs to Ethereum rather than Swarm.
I think we will have to wait until Ethereum and Zcash finally merge, because this has been like a love story for a long time, as far as I know. So who knows? Attila, I still have to ask you. Sorry, but Gregor had this wonderful question. No, sorry, Attila. I think it was a question for Dan, actually. Was it difficult, Dan? Sorry, Attila. I know it's like stupid. Dan, Gregor was asking, was it difficult to port from the old Swarm to the new B?
Yes and no. I think it's been quite difficult for me thus far because we didn't have the feeds implemented in the server's library. But once the feeds are implemented, then I think it's going to be very easy indeed.
Okay, thank you. I don't know if anyone has more questions. I don't have questions coming in, so I guess this means we can, close this live talk event and start hacking. I hope I'm gonna take a 30-minute break, and then I'm gonna, npm install BJS in my app. And I already updated the B node. That's working like a charm. And so I hope to see you all until late hours, European time, my time, in the Telegram chat group. I'll be hacking. I hope you all are also gonna do some interesting stuff. And of course, we can gather in GatherTown. There was an idea popping up of maybe, just pitching some of the ideas the hackers had in GatherTown, so people can see where they can join or what kind of technologies they use, or solutions they need. So let's say goodbye here and see each other in GatherTown. Yeah, good. Okay,
Bye-bye.
see you all. Bye. See you
Bye.
tomorrow.
Bye-bye.